Hi everyone. So in this video we are going to continue with embedding and also positional encoding. So embedding and positional encoding. Alright, so let me start by this. You see, for example, in the English dictionary or maybe in other dictionaries in other languages, there's a dictionary. So in English there's a dictionary like this, starting with maybe the letter A, then maybe apple. So this is a very small dictionary, to the word maybe zebra, right? And each word has a meaning. All right, so this is the human dictionary. Well, it turns out computers, at least in machine learning, there is also a dictionary, and that dictionary is what we call embedding. So the dictionary is something like this, starting with A. Well, now instead of the meaning or the sentence, we have a vector, and that vector can be something like this: 0.1, 0.2, 0.7, minus 1.9. And maybe B also has a vector of size 4, and that 4 is important. You see, in the previous video we said the embedding size is 4. So each of these words has a vector of size 4. Similarly, all the way to, well, our dictionary is character level, all the way to the $sign, there's a vector of size 4. Well, if our application was not character level, it will be the same as the English dictionary, but instead of sentences, of course, there will be, instead of characters in here, for example, there will be what? A, apple, all the way to zebra, but we're on character level. That's why we have A, B, C, all the way to $sign. And this, for our application, we said the embedding is 4. Well, depending on what you are doing or the size of the model, that can be 6, or maybe 8, or maybe 16. And this dictionary has a dimension, of course, of 65 by 4. All right, let me also mention that unlike, say, the English dictionary, the embedding dictionary can actually change. So these vectors can change. That is after in backpropagation. So I made a video on backpropagation, how the weight of embedding are changed. I will put it in the link below. All right. So this is the embedding dictionary. Now, in the previous video, we saw what X was. X was something like this: 11, 65, 638. Was it 11? This is 15, sorry. Then 63, 6, 14, 14. So of course, the index of A in this dictionary is 0, B is 1, all the way to this $sign. Hope you can see it, 65. So we're going to be using this embedding dictionary to convert our data. Well, the batch size is 2, so that's why I am drawing this into. So 11, well, 11 is maybe the letter N, and that vector is maybe something like this: 0.5, 0.2, minus 1.1, 0.9. 15 also has an entry of size 4. 63 has an entry of size 4. 18 has an entry of size, 8 has an entry of size 4. Similarly, 63 has an entry of size 4. 6 has an entry. 14 also has an entry. So the dimension of X used to be 2 by 4. Now this will be the new X, and the dimension will be from 2 by 4 to 2 by 4 by 4, because each of this is has been transformed to a vector of size 4. All right. So this will be the new X. All right. There's something very important, which is positional encoding. The positional encoding, okay, let's see this. Well, the new X that will come out of this layer, let's say xn, will be X, which is this, plus positional encoding of X. Well, think about it. Before actually transformers, there used to be models like LSTM, RNN, and these models process data in sequence. They will process, for example, 11, then 15, then 63. So there's this idea of order. So from here, from this. This is how they used to, the previous models process data, but transformers process everything at once, which means that the transformer model does not capture the order of the tokens, the characters in the input, which is why the idea of positional encoding was introduced, which actually adds information about the position of each character in the input. So this X is a tensor. The positional encoding of X will also be a tensor. X has a dimension of 2 by 4 by 4. The positional encoding will be 4 by 4. I'm not going to go in detail on positional encoding because I made a video about it. It's going to be in the description. To get the new xn, and positional encoding does not change the dimension of the input, which is X. Sorry, I'm using the wrong pen. Dimension will still be 2 by 4 by 4. All right, so now we are done with encoding, embedding. This xn is what is going to go into the subsequent layers. Thank you for watching. Bye bye.